So, hi guys, I hope you are doing well. So, let's finish this chapter, the logarithmic chapter, and let's start with the final topic of logs with straight line graphs. Okay, logs applied with straight line graphs. So, basically, when we are given an expression in a power form or any other form, and we are asked to construct a graph in logarithmic terms. For example, our y-axis is a log term and our x-axis is also a log term. So we follow a certain criteria, we follow a certain set of steps to get the answer. You know, for the first step will be we convert our given equation into log form. And how do we do that? We basically take logs on both sides. So we basically take logs on both sides. Secondly, what we what do we do is we isolate our terms. We isolate our y-axis and our x-axis terms. So we isolate our y-axis and x-axis terms. Okay? And then for the final step, we compare it with our straight line graph. Straight line graph, which has a basic equation of y is equals to mx plus c. And so when we follow these steps, we basically acquire our desired values. So we get m and c, our gradient and our y-intercepts, and these gradients and y-intercepts help us to determine our unknown constants or our unknown values. So let's take a look at some questions to better grasp this concept, because I know that you guys didn't get much of a hold of it. So answering the questions will definitely help you get quite some hold on it, or to fully understand the concept we need to solve some of the questions. So for example, we have our equation of t is equals to 2l raised to the power of n divided by c, and c and n are constants, and a graph is plotted of lgt on the y-axis. So my x-axis term is the y-axis term is the lgt, or the log of t with log with the base of 10 on the y-axis, and my LGL is basically my term on the x-axis. So what do we do? Our first step is basically taking logs on both sides after we make t the subject, because in the equation of the straight line, which is y is equals to mx plus c, y is alone, it is alone. So our y-axis term should be alone. So my y-axis term is basically LGT. And so t is already on the left hand side. So that solves a part of the question. And now taking log with the base of 10 on both sides will completely, solve the question at least a 50% about. So taking LG on both sides. Taking LG both sides. Okay. So LGT, yeah. So LGT is equals to LG2L raised to the power of n c. So now what do I have is my LGT, or my y-axis term, is already isolated. But there's a little problem. My x-axis term is not isolated. It is not alone. And by alone, I do not mean that it is absolutely unknown. There is no other value beside that. I mean that it is not clearly expressed. My y-axis term should be isolated and it should be alone as it is on the left hand side, but on the right hand side or on the other side, my x-axis term should be alone and it should not be isolated. I think isolated is not a good word. So the word you should use is that it should be alone. It should be clearly expressed. So my left hand term, or sorry, my LGL on the x-axis, my x-axis term, which is basically log with the base of 10 argument of L, should be clearly expressed. And I cannot see that, I could not see that. What I can see is that it has a coefficient of 2, it has a power of n, and it is divided by the constant c. And that does not clearly express it. It should be clearly expressed in the terms of LGL. So I need to make LGL. I need to make LGL. And how will I do that? I can do that by taking the quotient rule, by applying a quotient rule. So Lg 2L raised to the power of n negative LGC, and so further I can see it is not clearly expressed, but I can do that because I can apply the power rule or product rule here. So it becomes Lg 2 plus L n negative LGC. Okay, wait a minute. Lg L raised to the power of n negative LGC, and I can apply the power rule here, and LG2 plus n LGL negative LGC, and so what does it become? It becomes LGL to the power base coefficient of n plus LG2 negative LGC, and now I can see my x-axis term is isolated. It is expressed. I can express my x-axis term. It is not isolated, it is expressed. It is clearly expressed. I can see in my equation the LGL. So finally it becomes LGT is equals to N LGL plus LG2 negative LGL. Okay? LGC. LGC. Yeah. So let's compare it for our final step. Let's compare it with the equation of the straight line, which is y is equals to mx plus c. And so I can see that my y is LGT, my x-axis is LGL, and so my gradient, so what will be my gradient? It will be m will be my constant n, and my y-intercept will be Lg2 negative Lgc. So m is n, and while my c is Lg2 negative Lgc. So my gradient is n, and my y-intercept is Lg2 negative Lgc. Okay, so let's do another question to fully understand the concept again. So I've been given the equation of y is equals to ax raised to the power of b, and I'm asked to plot a graph of LGY against LGX. So my LGY is my y-axis and my LGX is my x-axis. So what does that mean? It basically means that if I construct a graph of LGY upon LGX, I get a straight line, you know? So what do we do? Again, first we write our given equation, and so my y-axis is already isolated on the left hand side, so I just need to take LG on both sides. So taking LG both sides, and that solves part of the question. LGY is equals to LGAX raised to the power of B. And so what I can see is my LGY is already isolated. LGY is already isolated, but my x-axis term, which is basically LGX, it is not clearly expressed. Not clearly expressed, and I need to express it. I need to express it so that further down the road or further down the question, I can compare it with my equation of straight line. So I'm just going to express my x-axis term, and so I'm going to apply the product rule here, and LGA plus LGX to the power of B and BLGX plus LGA. I just rearranged the question and I applied the power rule to x to the power of B. Okay, so it becomes B becomes the coefficient of the entire logarithmic expression, which is LGX. So LGY is equals to B LGX plus LGA. And now when my y-axis term and my x-axis term both are expressed, and now both are expressed, and my LGY is isolated on the left hand side, and my LGX is also expressed, not isolated but expressed. Now I can compare it with my equation of straight line, which is y is equals to mx plus c. And so y becomes my LGY and my x becomes my LGX. And so my gradient, what does my gradient become? It becomes constant B, and my y-intercept becomes my LGA. So let's calculate the gradient, and because gradient is equals to B is equals to 4.37 negative 0.57 upon 5.36 negative 0.61. I just applied the formula of the gradient, which is y2 minus y1 is equals to x2 minus x1. So I get my answer of 0.8. So my B is 0.8. Now, as for my C, what I'm going to do is I will rewrite my equation of straight line, which is y is equals to mx plus c. And so what is my y? Well, I'm going to use the coordinates for this question. I'm going to use this coordinate of 5.36 comma 4.37. So my y is 4.37 is equals to my gradient, which is 0.8 into x term, which is 5.36 plus c, and 4.37 negative of 0.8 into 5.36 is equals to c, and my c is basically 0.082. And since my c is equals to LGA, okay, so log with the base of 10 or 10 raised to the power of 0.082 is equals to A. And so my A is, oh no, yes. So my A becomes 1.21. So my final answer, let me highlight it for you to clearly see. So it's 1.21 as of A, and B is 0.8. Wallah. So let's continue. Using your values of A and B, find the value of y when x is equals to 3. The value of y when x is equals to 3. So let's just use the equation LGY is equals to LGA plus LGX to the power of B. So the question asks me to find the value of y. So what I'm going to do is I'm going to collect my logarithm terms on the right hand side into a single log. Okay, so since log on the both sides can cancel out if they have the same base, and both of them have the same base of 10, and now I can equate both terms, both arguments. Y is equals to a x to the power of b, and what is my a? It is 1.21. And what is my x? Well, it is 3. It is given in the question, or in this part specifically, and my b is 0.8. And so my answer comes out to be approximately 2.89. That wasn't really difficult. So the value of y when y is equals to 3. Well, the question first asks us to calculate the value of y when x is equal to 3, and now the value of x when y is equals to 3. So let's just again rewrite the equation, which is LGY is equals to LGA plus LGX to the power of b. Okay, so LGY negative LGA is equals to BLGX. I just applied the power rule here, and I took my LGA on the left hand side, and now I will make it a single logarithm, and because of the negative sign between them, I'm going to apply the quotient rule, so it becomes y divided by a. Well, it is equals to B L G X, and so oh no, I don't think so. It doesn't help me bit. So I shouldn't have applied the power rule here. So it just becomes LGX to the power of B. I'm just going. I'll just reverse again. I'll just attempted a reverse gear because it didn't help my cause. And now since both of these logs have the coefficient of 1, I can equate them. Their arguments can be equal, and now I can cancel the logs because they have the same base. So y upon a is equals to x to the power of b. And what is my y term? It is 3 upon what is my a term? It is 1.21. And what is my power? If it is, what does it equate to? It equates to x to the power of b. Well, if you have ever studied in indices, which I really hope you have, b, when the power goes to the other side, it becomes the reciprocal power. So it becomes 3 upon 1.21 to the power of 1 upon zero point 0.8, because b was equal to 0.8, so it basically becomes 1 upon b, 1 upon b, which is 1 upon zero point 0.8, and so my final answer comes out to be 3.14. Okay, so let's take a look at this final question, which will really help you ease your concerns. And I hope now your concepts are already very much clear. So let's take a look. Variable x and y are such that when ln y is plotted against ln x, so I know my y term is basically ln y and my x term is already ln x. A straight line graph. Well, straight line means y is equal to mx plus c is applicable, passing through the points 6, 5 and 8, 9. Okay, so I've been given the two coordinates, and show that y is equal to e to the power of p x to the power of q, where p and q are integers. So what is my given equation? It is e to the power of p x to the power of q. So my y term is already isolated on the left term, on the left hand side, so just taking the ln will clearly express the y term. Okay, so taking ln both sides. Okay, so it becomes ln y is equals to ln e to the power of p x to the power of q. Well, my x term, which is ln x, is not clearly expressed. My right hand side is ln e to the power of p x to the power of q. So to clearly express my x-axis term, I'm going to apply the power rule, the product rule. So let's just do exactly that. Ln x to the power of q, and let me rearrange this: ln x to the power of q plus ln e to the power of p. Okay, so let's apply the power rule, and now my x-axis term is clearly expressed: ln e to the power of p. I can see that my ln y and my ln x are both clearly expressed, and my y term is already isolated on one side of the equation, just as in y is equal to mx plus c. And now I can equate my equations with a straight line graph. Let's just do that. Mx plus c. So, well, y becomes my ln y, my x becomes my ln x, and the other term m becomes my q, and my c becomes ln e to the power of p. So my m, or my gradient, is basically q, and my y-intercept is basically ln e to the power of p. Well, if I apply the power rule here, so p ln e is equals to y-intercept, and p ln e becomes 1. So basically my p is also equals to c. So my p constant is basically my y-intercept, and my gradient is basically my q term. So let's calculate the gradient, and I've been given the coordinates of 6, 5 and 8, 9. So it becomes 9, -5 divided by 8, -6. So it becomes 4 upon 2, it becomes 2. So my q, which is basically my m, which is basically my 2. Okay, so let me highlight it. This. And for my y-intercept, I'm going to rewrite my equation y is equals to mx plus c. Since now we have converted our logarithm expression into a straight line graph, so it becomes y is equals to mx plus c. And so my y term is basically, let me use a coordinate of 8, 9. It's 9 is equals to 2 into x term is basically my 8 plus y-intercept c. Okay, so it becomes 9 -2 into 8 plus c. 9 -16 is equals to c, and c becomes -7. So the question asked us to show that y is equals to e to the power of p, x to the power of q. So it's basically y is equals to e to the power of p, x to the power of q, and so it becomes y e to the power of p, which is my y-intercept, which is basically my -7, and my x is basically my gradient, which is basically my 2. So this equation is our final answer. So that's it. That pretty much sums up the entire chapter of logarithms, including the questions too. And I attempted some really challenging questions, and I think, or I really hope, your concepts are pretty much clear. And with this, we wrap up the O-Level IGCSE and GCSE Add Maths syllabus for logarithms, and as well at the same time Edexcel IGCSE further pure maths. So yeah, see you in the next class, or in the next class of the next chapter. Adios.